Good day, grade 12 learners, and welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So now for today's knowledge area, we'll be focusing on magnetism. And with that, we are going to be focusing on your electricity, and of which electricity is then going to be in your paper 1 for the examination. And it has a total of what, for your paper 1, we have a total of 150 marks there. Now, this would be your mark allocation, that is in terms of your paper 1. So it consists of your section A, which has 10 multiple choice questions, which have a total of 20 marks. And then under section A again, we are going to have either 8 matching items or 8 one-word items, which has a total of 8 marks there. And then we have your section B, which consists of structured or long questions and has a total of 122 marks there. Now for the total for your paper 1 will therefore be 150 marks, and that is with a duration of what? Of 3 hours there. Okay, and for the topics to be covered in paper 1, we have your mechanics, which has a total of 93 marks and a percentage weighting of 62. Then we have your electricity and magnetism, which has a total of 33 marks there and a percentage weighting of 22. And then the last one that we have there would therefore be your waves, sound, and light, which has a total of 24 marks and a percentage weighting of what? Of 16 there. Okay, so now this is what you would have then covered, that is in terms of your grade 10. So in grade 10, we learned about what? We learned to define current, and current is therefore represented by what? Is therefore represented by the letter I. And we learned that current is the what? Is the rate of flow of what? Of charge. And therefore the current is measured in what? The current is measured in ampere. So if current is the rate of flow of charge, it therefore means that we are going to explain it using which formula? We are going to explain it using this formula here to say that it will be the what? The rate. So by the word rate then, it therefore means that we will be referring to the change in time. So the rate of flow of what? Of the charge. So we'll be referring to the Q there, which is measured in Coulomb. Remember the time there, we measure it in what? In seconds. And then it says that the current is measured in what? The current is measured in ampere. So remember, in grade 10, we also learned that for us to measure the current, what is it that we are going to use? We are going to use an ammeter. And then you also learned how to identify what? How to identify the current on a circuit. So how would you then represent it? Or how would you then identify it? You would identify it or represent it as a circle with what? With the A inside. So that would be your what? That would be your ammeter. And it would be there to measure the what? It would be there to measure the current there. Okay. Then again in grade 10, you learned how to define what? How to define the terminal potential difference. And that is in terms of what? In terms of the work done and the charge. Okay. So terminal potential difference, which one are we then referring to? It therefore means that we are referring to the V there. And it says here the terminal potential difference in terms of what? In terms of the work done. So that means that we are referring to the W, which is the work done, and the Q, which represents what? Which represents the charge there. And then the next one says, give the difference between what? Give the difference between the EMF and the terminal potential difference. So now remember then, the EMF is what? The EMF would be the voltage that you are going to measure across the battery when the what? When the switch is what? When the switch is open. And then the terminal potential difference would therefore mean what? Would therefore mean that the voltage that you are going to measure across the battery when the switch is what? When the switch is closed in the circuit. And then you needed to define what? You needed to define the resistance as the opposition of the flow of what? The opposition of the flow of electric current. So now remember, how do we represent the resistance? We represent the resistance using the word, using the letter what? Using the letter R. And therefore, the resistance is measured in what? The resistance is measured in ohms there. And then it says, state and explain the factors that affect the resistance of a substance. Now, one of the factors would be what? Would be in terms of the wire. So we are saying that if we are going to have what? If we are comparing a longer wire as compared to what? As compared to a shorter wire, where are we going to have more resistance? Now you would imagine that if the current was to be traveling in between the two wires, where is it going to take much more time to travel? It is therefore going to take much more time to travel where in the longer wire there as compared to the shorter wire. So therefore, one of the factors would be that if we have a longer wire would therefore offer what? It would therefore offer more resistance as compared to us having what? As compared to us having a shorter wire there. And then again, in terms of the thickness of the wire, if we are to compare the thickness that we are going to have, we are therefore going to say that, so if we compare a thin wire and as well as a thicker wire, we are therefore going to say that a thicker wire is going to offer what? Is going to offer less resistance as compared to what? As compared to a thin wire there. And then another factor would be what? Would be the type of conductor, okay? So therefore we are saying that a better conductor would therefore mean that we are going to have what? We are going to have less resistance there. Okay, so learners, if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578 and 2908 there. Okay. Then in grade 11 again, you learned what? You learned how to define what? Ohm's law in words. And then you also learned, it says here, determine the relationship between what? The current, the voltage, the resistance at constant temperature, and that is using what? Using a simple what? A simple circuit. And then you needed to state the difference between an ohmic and a non-ohmic conductor, and also be able to give what? Examples. Then it says solve problems using what? Series and parallel circuits, but up to a maximum of what? Of 4 resistors. Then it says use series and parallel resistors in combination with what? With Ohm's law. So in grade 11, again, you were able to use a combination of the series and the parallel resistors. And with that, you were able to calculate or do calculations based on what? Based on Ohm's law. Then it says define EMF as the potential difference across a cell when the circuit is what? When the circuit is open. So we spoke about this one. We said that the EMF would be the voltage, or it would be the potential difference that you are going to measure. That is if you connect what? That is if you now connect the voltmeter on your battery, and you will then be measuring the potential difference, or you will be measuring the voltage only when what? When the circuit is what? Is open. Now, the next one then says define internal resistance as the resistance inside the cell when the current flows through it. So internal resistance would be the resistance that you would be getting inside the cells or inside the battery. But when what? When the current is flowing through what? Through the cell. And then it says that when it comes to the internal resistance, then we do not need to calculate them. Then next, so now with your grade 12, we have power and energy. And it says here, define power as the rate at which electrical energy is converted in an electric circuit. And then it says here, the SI unit for power is what? The SI unit for power is what? Which can then be represented by what? Which can then be represented by the letter W. Then it says the practical unit of power is kilowatt hour. And then you need to be able to solve problems using the following formulas. So it would be the work done divided by the change in time there. And then it would be the voltage multiplied by what? Multiplied by the current. And then again, the current multiplied by the what? The current multiplied by the resistance. So again, you needed to be able to calculate what? Power, the work or the energy, time, the voltage, the current, as well as the what? As well as the resistance. Then it says, deduce that the kilowatt hour, which is kWh, it refers to the use of what? 1 kilowatt of electricity for how many hours? For 1 hour. And then calculate the cost of electricity usage given the power specifications of the appliances used as well as the duration if the cost of 1 kilowatt hour is what is given. And then the last one, according to what you need to know, it says the heat produced by the resistor in a circuit is therefore given by the following. So it would be I squared R multiplied by what? Multiplied by the change in time. So you need to make sure that you know how to use what? How to use, make use of this formula as well. Okay, so now it says here, define current. So we said current, we are going to represent it using what? Using I as the what? As the rate of flow of what? Of charge. So meaning to explain the definition, which formula are we then using? We are using I, which is equals to what? I, which is equals to Q divided by the change in time, whereby the I will represent the current, which is measured in what? Measured in ampere, and the Q will represent the what? Will represent the charge, and then the change in time is what defines the rate of flow. Okay. Now it says is the amount of charge that is moving through a certain point in what? In 1 second. Okay. So if they now ask you in a multiple choice question, what is the unit or the SI unit of what? The SI unit of current. The SI unit of current is what? It is measured in what? In ampere. But what is it that we have on the right hand side? We have the charge divided by what? Divided by the change in time. So therefore, what is the unit that we are going to use to measure the charge? It's going to be what? It's going to be what? Coulomb. And what is the unit that we are going to use to measure the time? It's going to be second. So right now it therefore means that we have an ampere is equivalent to what? Is equivalent to Coulomb per what? Coulomb per second. So this can come up as one of the multiple choice questions to say maybe that 1 ampere is also equivalent to what? So therefore 1 ampere will be equivalent to Coulomb. That is what we have there according to the unit there. Coulomb per what? Per second, and that is what we have there as well according to the change in time. So if they ask you, you would therefore say that 1 ampere is therefore equivalent to what? To 1 Coulomb per second, because the 1 Coulomb per second represents what? Represents the same unit of what? Of ampere. Then it says define the terminal potential difference in terms of the work done and the what? And the charge. So for the terminal potential difference, we have the formula of what? V is equals to W divided by what? Divided by the change in time. So it says in terms of what? In terms of the work done, which is our W there, and the what? And the charge. So it therefore means that with the definition, then we are given the what? We are given the formula as well. So with the potential difference, what is the unit? What is the unit that we are going to measure the potential difference with? The potential difference is measured in what? It's measured in volts there, okay? And the work done is therefore measured in what? The work done is measured in joules, and the charge is measured in what? The charge is measured in coulomb, which is a capital letter C. So it therefore means that V, which is there for the potential difference, is equivalent to joule per what? To joule per coulomb. So therefore, if they then ask you in the examinations, you would therefore say that 1 volt is equivalent to 1 joule per what? 1 joule per coulomb, which is coming from where? Which is coming from the formula of the potential difference. Then it says the work done per unit charge by the electrons, the work done per unit charge by the electrons as they move through the cell or through the resistor there, okay? And for the next one then, it says we have what? We now have what we call what? A series circuit. So with a series circuit, you need to make sure that you know how to identify the components that we have, as well as with a what? As well as with a parallel circuit. So now we can see that we have what there? We have what we call a battery. But if we're just going to have what? The one line and the short line, well, remember, we would therefore be calling it a cell. So we have a battery there, and then the letter A there in the circle, it therefore means that we have what? We have an ammeter, which is going to be measuring what? Which is going to be measuring the current. And then these ones here are therefore going to represent what? Are therefore going to represent the light bulb. Or in other words, we can also call it what? We can also call it a resistor. And then remember, we have what we call what? Conventional current. So if you are trying to determine in which direction will the current flow, we are therefore going to use conventional current. And with conventional current, what are we saying? We are saying that the current is going to move from the positive terminal to the negative terminal. So which one is the positive terminal? The positive terminal is represented by the longer line, and the negative terminal is represented by the shorter line. So if you are to draw the movement of the current is therefore going to be moving from the left to the right, because we are using conventional current, and then we are saying with conventional current is going to flow from the positive terminal, which is the longer one, to the negative terminal, which is the shorter line. So now with a series circuit, it says in a series circuit, all the components, they are connected one after the other. So all the components, so this is our ammeter, this is what? This is the light bulb, which is serving as a resistor. They are all connected one after the other. So on this diagram here, it therefore means that this is our light bulb. So the same light bulb that we have there, that is our light bulb, and it's serving as a resistor. And this one here would therefore mean that it is representing our what? It is representing our switch. So again, if we are to then draw the switch here, this would be representing the switch when it comes to this cell. And this one here, what does it represent? We can see that it's written current, and it has a value of 0.30 ampere. So therefore, it represents what? It is the same as that component there, which represents the ammeter. Then on this side here, we have what? We have the voltmeter, and we can see that it has a voltage of what? It has a voltage of 9 volts. So if we are to connect the voltmeter here, therefore, it would be represented in that way. So it would not matter if from the picture here, you can see that it would not matter if we represent the voltmeter at the bottom here, or if we represent it, if we then draw it and represent it where, and then represent it at the top, because these ones are just the connections of the what? They are just the connections of the voltmeter. So it therefore means that we can connect the voltmeter, we can put it this side, or we can also represent it and put it where? And put it outside of the circuit as well. Then it says there is only one path for the current to flow, and that is from the positive terminal of the battery to the what? To the negative terminal of the battery. So again, we said that we are going to use conventional current, and then we are also saying that with a series circuit, there is only one way for the current to flow. So we are therefore saying that the current is what? The current is not divided. Okay. So even if we can look at the arrows here, we can see that if we follow the arrows, there is only one pathway for the current to flow. And remember, we said that the current will flow from what? So it means in this case, if it's flowing to the right, it will mean that the current is flowing from the positive terminal to the negative terminal over there. Okay, so that is our series circuit. What's important to note is that there is only one path for the current to flow, and that current will then flow from the what? Will then flow from the positive terminal to the negative terminal. Then it says in a series circuit, the current remains the same at all the points in the circuit. So it therefore means that if we are then, so with this diagram here, what we did is we then added to the what? We then added the ammeter so that we can be able to see the what? So that we can be able to read the current. As the statement says that in a series circuit, the current remains the same at all the points. So you will then see that if you are to take a reading of the current where at this point, the current is reading what? 0.3 ampere. If you are to take a reading of the current, so in between the light bulbs there, the current is reading what? 0.3 ampere. If you take a reading there, the current, because now it's a series circuit, the current is still reading what? 0.3 ampere. Again, if we take a reading of the current over there, the current is still reading what? Is still reading 0.3 ampere. So we are therefore saying that if you are to measure the current, so even if you are to take it there, so if we are to place ammeters there and we measure the current at all the points, because it is a series circuit, therefore the current will be the same. So for example, this one would be representing what? I1. This one would represent I2. If we then had I3 and as well as what? As well as our I4. So we are therefore saying that the current for I1 will be equal to the current for I2, will be equal to the current for I3, and will also be equal to the current for I4 there. Okay, then it says the voltage in a series circuit. In a series circuit, the voltage across the battery is divided across each resistor connected in what? Connected in series there. Okay, so if we are then so on the following circuit there, we've got what? We've got two resistors. And what are those two resistors? The two resistors are the light bulb there. So we are therefore saying that when it comes to a series circuit, the voltage is what is divided across each resistor. So we are therefore saying that if we had a voltmeter there, the voltmeter would therefore be reading a total of what? would therefore be reading a total of 9 volts. And where would the 9 volts be coming from? It would be coming from the 4,50 and the 4,50. So we are therefore saying that if we have two resistors and we are asked to calculate what? We are asked to calculate the total voltage. This is what we are going to do. We are going to look at the voltage that we have for each of the light bulbs. So for example, if this one then is representing what? A light bulb R1 and light bulb R2, we are therefore saying that, again, this can also mean that we can therefore call this one V1 and we can also call this one V2. So we can see that for V1 and V2, we have the values. So if you are to calculate, it would therefore be 4,5 plus by what? Plus by 4,5, and that would give you a V total of what? A V total of 9 volts. So we are saying that the potential difference. GPS signal lost. We are therefore saying that the potential difference is what? The potential difference is divided. Okay. So if the potential difference is then divided again, we are saying that V1 and V2, they would give us what? They would give us V total there of what? Of 9 volts. So it depends on how many resistors you have. If you have 3 resistors, it therefore means that you are going to go on and calculate what? And calculate V3 as well. Okay. And the next one says voltage in a series. Okay. So again, with this one here, remember we said that the current is what? The current is the same in a series circuit. So right now, if you look at the battery there, what is it that you are given? You are now given the total voltage. So if you are now asked to calculate, we said that if this one represents what? So if this resistor represents V1 and this resistor represents what? V2 there. And then you are then required to calculate, let's say V1, this is what you are going to do. V total plus is equals to V1 plus by what? Plus by V2. So let us now look, if we now have a total voltage of what? If we now have a total voltage of 9, where's the total voltage coming from? It's coming from the battery there. So if we now have a total voltage of 9 and we have what? We have an unknown V1. So we did not connect the voltmeter there. So if they now say you must calculate V1, so you are therefore going to write your V1. And what is it that you have? We can see that for V2, you have what? You have 4,5. So how would you then calculate V1? You would therefore say V1 is equals to what? 9 minus 4,5 there. And that would mean that you have what? 4,5 volts. So basically, again, we are therefore saying that in a series circuit, the potential difference is what? The potential difference is divided. That means that some of the voltage will then be divided amongst what? Amongst R1, and some of the voltage will be divided amongst what? Amongst V2 as well. Okay. So learners, I'm going to ask that we take a 2 minutes break, learners, a 2 minutes break. Welcome back, learners. So if you have any questions, you can send your questions to the following WhatsApp number, 079-578-2908. So again, if you have any questions, learners, you can send your questions to the following WhatsApp number, 079-578 and 2908 there. Okay, so now we also have what? We also have the resistance in a series circuit. So remember, the resistance, we are going to represent it using what? Using the letter R. And we measure the resistance using what? Using the symbol what? Using the symbol ohms there. And then it says in a series circuit, the total resistance is the sum of the resistance of what? Of each resistor. Okay, so firstly, what is it that we can see here? We can see that we have the longer line, which is the positive terminal of the battery, and the shorter line, which is the negative terminal of the battery. And then we would then have to identify what? There is our current flow. Because according to conventional current, we said that current flows from the positive terminal to the negative terminal. Okay, so again, this one here would also be another representation that we can use for the what? For the resistance. So in this case, how many resistors do we have? We can see that we have 2 resistors. So therefore, if you are then to calculate, it therefore means that you are going to say what? You are going to say that you have your R1, and your R1 is represented by what? Is represented by 50 ohm, plus by what? Plus by your R2. So let's say now in this case, this one represents R1, this one represents R2. But of course, in the examination, they will tell you which one is representing an R1 and which one is representing R2. So, but for now, we are saying that, let's say now, this is R1 and that is R2, or this can be R1, that can be R2. So we are then going to do what? We are then going to substitute, and we can therefore get our answer as 100 what? 100 ohms there. Okay, so just make sure that when it comes to a series circuit, you understand all of the above. So you need to understand that number 1, we said what? The current is the same throughout all the points. Number 2, we said that if we look at the 2 resistors, we said that what is going to happen when it comes to the potential difference. The potential difference is what? Is divided. So because it's divided, that is where we are then going to use what? V1 plus V2 plus V3. And that will depend on how many of the resistors that we have. Like on this one, we said that we only have R1 and what? And R2. That is why we are not going to include what? That is why we are not going to include R3. But if you have R3, then you are then going to continue and add what? And add plus by what? Plus by R3 there. Okay. Then next we have a parallel circuit or a branch circuit. It says a branch circuit forms when resistors are connected in what? When resistors are connected in parallel. So again, remember, we still have the knowledge of what? We still have the knowledge of current will then flow from the positive terminal to the negative terminal. So still using the very same knowledge, it then says there is more than what? There is more than one path for the current to flow, and the current still is flowing from the positive terminal to the negative terminal. So if the red arrows are representing the current, if we are saying that it's going to flow from the positive, so if the current is going to the right, it therefore means the right is our positive terminal, and the left is our negative terminal there. Okay, so with the series circuit, we said there's only one path. Okay, so but with the parallel circuit, we are therefore saying there is what? There is more than one path. So if this is the current now, it's passing through what? Through the what? Remember we said that this is the ammeter. So if this is the current, the red lines are the current, and they're passing through the ammeter and then passing through the other part of the wire, we can see that what is happening when the current gets there. When the current gets there, some of the current then moves to the left. So it moves to one of the what? It moves to one of the light bulb. And then the other current, where is it moving? The other current is moving to the other light bulb, which is at the bottom there. So therefore, it therefore means that we can then conclude that there is what? There is more than one path. So it does not travel just in what? In one direction. some of it will go onto this light bulb here, and some of the current then goes to the other light bulb until what? Until the current then comes together there at this point here. And that is where, if we are to place an ammeter there, we can therefore be able to read what? We can therefore be able to read the total current in the circuit there. Okay. Then it says current in a branch circuit. So it says in a branch circuit, the current divides between the resistors connected in what? Between the resistors that are connected in parallel. So because the current then divides, it means that we are going to use this to calculate the current. And then it says the larger current passes through the smaller resistor. Okay. So what's important to note, it says that the current divides. So parallel circuit, they are what? They are current dividers. So what does it mean? We can see that on the ammeter reading here, we have what? We have a reading of 1.8 ampere. But because we said that the current will then divide, it therefore means some of the current is going to travel to this light bulb, and some of the current is going to travel to the light bulb at the bottom. So if that's the case, it therefore means that some of the current from the total current, we are going to have what? We can have 0.9 for this light bulb, and then we can have 0.9 for the light bulb where at the bottom. So if you are to calculate the total current, you are therefore going to use what? You are therefore going to use this formula. So again, if you have 3 ammeters, it means that you are going to have what? Plus 3. But because now we only have 2 resistors, therefore we are only going to calculate what? I1 plus by I2. So let's say now we want to calculate the total current in the parallel part of the circuit. In the parallel part of the circuit, it would be where what? Where the current is what? Where the current is divided. So what is it that we are going to do? It means that we are saying that if the light bulb at the top, we are going to call it R1, and the light bulb at the bottom, we are going to call it R2. For the light bulb at the top as well, we can call it what? Our I1, and the light bulb at the bottom, we can call it our I2. So for the light bulb at the top, we can see that we have a reading of what? Of 0.9, and for the light bulb at the bottom, we have a reading of another 0.9. So therefore, the total current would therefore be what? 1.80 ampere. And where can we see that? We can see that, so this portion here at the top, it represents what? It's a series circuit. This is where now we have the total current. And then after now, the current then travels and goes through the 2 light bulbs. The current is what? The current is divided at this point here. And then if the current then gets divided, at this point, we can see that the arrows are now coming together to form a straight line. So therefore, we are therefore saying that again, if we are to place an ammeter here, it would therefore read the what? It would therefore be reading the total current, which is the same as what? Which is the same as 1.80 what? Ampere. Why? Because we are saying that the top part of the circuit, it represents what? It represents a series circuit. And with a series circuit, we are saying that the current is the same at all the points. But with a parallel circuit, we are saying that the current is what? The current is divided. And then another thing that we can note is that just because this is 1.80 and this is 0.9 and 0.9, we are therefore not saying that the current will be divided equally. And then another one, it says here, the larger current passes through the smaller what? The smaller resistor. So therefore, it means that we are looking at the relationship between the resistance and the what? And the current. It says if we have a larger current, so meaning that the greater the current, it will pass through a smaller resistor. So therefore, it means that we are talking about the relationship between what? The relationship between the resistance and what? And the current. And we can see that they are inversely proportional. Why? Because we are saying that if we are going to increase the current, therefore the resistance will do what? The resistance will decrease there, or vice versa. Next, it says in a branch circuit, the voltage across the resistors connected in parallel is the same, even if the resistors are what? Even if the resistors are different. So remember, the light bulbs, they are serving as what? The light bulbs are serving as our resistors. So we spoke about the current in a what? In a parallel circuit, we said the current is divided. That is why we have that. But now when it comes to what? When it comes to the voltage, we can see that on the battery here, we have a total voltage of what? We have a total voltage of 9 volts. But if we are going to measure, the voltage, where the voltage on this resistor here, at the resistor at the top, we can see that the voltage is given by what? The voltage is given by the very same 9 volts. And then again, if we can measure the voltage on the resistor at the bottom, we can see that the voltage is given by what? Is also given by 9 volts. So simply we are saying that in a parallel circuit, the voltage is what? In a parallel circuit, the voltage is the same. And in a series circuit, we are saying that the voltage is what? Is divided. And in a parallel circuit, we are saying that the current is divided, but in a series circuit, we are saying that the current is the same. Okay. So next we have resistance in a branch circuit. So it says in a branch circuit, the equivalent resistance of the branch is calculated using what? Is calculated using this equation. So obviously then, if you are to calculate your what? If you are to calculate your resistance, it would therefore mean that you would then again have to look at how many resistors do you have. So if you have more than one, then it therefore means you are going to have what? 1 over Rp, which represents what? The total resistance in parallel, is equals to 1 over R1 plus by 1 over R2 plus by 1 over R3. But in this case, we can see that we only have what? We can see that there's only 2 resistors. So it would therefore mean that you are going to use what? We are going to use 1 over Rp, which is the resistance in parallel, is equals to 1 over R1. So it means that between the 2 resistors, one will be representing R1 and the other one will be representing R2. So it's equals to 1 over R1 plus by what? Plus by 1 over R2 there. Okay. So therefore, if you are then asked to calculate the resistance in what? The resistance in parallel, it would therefore mean that you would then say 1 over Rp is equals to what? 1 over 10 plus by 1 over 10. Okay, so from there, you would then get your answer. And then how would you then solve it? You would then solve it by cross multiplying, so that you can then get your answer for what? So that you can then get your answer for Rp over there. Okay. And then with Ohm's law, so it says here, state Ohm's law in words. So remember, with definitions, we are saying that you need to define according to what? You need to define according to the examination guideline. And then we are saying that with definitions, your definitions are going to be 2 marks or nothing. So make sure that you know all those definitions that are given according to the examination guideline. So it says the potential difference across a conductor is directly proportional to the what? Directly proportional to the current in a conductor, and that is at a constant what? At a constant temperature. So remember, the full definition ends where? The full definition ends where we have the full stop. So if that's the case, it means that when you define, you're not just going to say the potential difference across a conductor is directly proportional to the current, because that will then be a half definition. So you need to define it all the way up until what? Up until at a constant what? Temperature. So this formula would therefore represent what? This formula would therefore be representing Ohm's law, okay? Whereby R represents the the resistor or the resistance in what? In ohms, and then V is the potential difference in what? In volts, and then the I would represent the what? The I would represent the current. So it says the potential difference across a conductor. So this one, the potential difference across a conductor is what? Is directly proportional. So it's directly proportional to the what? To the current. So V is directly proportional to the current. V is directly proportional to the current, but that is at a what? That is at a constant temperature. Remember when we say that V is directly proportional to the current, what are we saying? We mean that as the potential difference increases, the current will also what? The current will also increase there. So again, on the graph, we have what? On the graph, we have the potential difference and the what? The potential difference and the current. So you can be given a graph and they can ask you to do what? They can ask you to calculate the resistance. So if you are to calculate mathematically, if you are to calculate the gradient from the graph, what is it that you are going to do? You know that the gradient is given by what? M is equals to change in Y divided by what? Divided by change in X. By change in Y, we are talking about what? We are talking about the Y-axis, and then by change in X, we are talking about what? We are talking about the X-axis. So with that, we are therefore saying y2 minus what? Minus y1 divided by x2 minus x1, okay? But we can see that according to the graph, what is it that we are giving? According to the graph, we can see that on the y-axis, we have the volts, which is the potential difference, and then we also have the what? We also have I, which represents what? Which represents the current. So from here, what is it that we are going to do? It therefore means that if we are to represent whatever that we have on the graph, but according to Ohm's law, then this is what we are saying. We are saying that we have M is equals to what? Change in V. Where's the change in V coming from? The change in V is the same as on the y-axis, I have change in V and divided by what? Divided by change in what? Change in I there, okay? So the change in I, where is it coming from? We can see that on the x-axis, we have what? We have I there. So therefore, if you are to calculate, it would be V2 minus V1 divided by what? I2 minus I1. But again, you can also represent it in this way by saying y2 minus y1 is equals to what? Is equals to x2 minus x1, okay? But in this case, we are saying here that we have change in V. Change in V is what? Is the y-axis. And then change in I is the what? Is the x-axis. Again, I'm saying which is the same as what? Which is the same as us saying change in y divided by change in x. Now, if you look at this change in V divided by change in I, you will see that it is the same as what? It is the same as whatever that we have, that is in terms of what? In terms of Ohm's law. So for Ohm's law, we have what? We have V. And then at the top here for the gradient, we have change in V. And then for Ohm's law at the bottom, we have I. And at the bottom here, we have what? We have change in V. So therefore, it means that whatever that we are going to get as our gradient, it therefore means that it would be representing what? It would be representing the resistance in what? In ohms. So let's say now in the exam, they now ask you to calculate what? They now ask you to calculate the resistance. So therefore, this is what you would then do. It means that you would then choose any of the 2 points, where on the graph, and then you can then say what? Y2 minus Y1 divided by X2 minus X1, or V2 minus V1 divided by what? X2 minus, I2 minus I1, okay? So again, then from your graph, what is it that you're going to do? So you know that whatever that we have here, it's going to represent what? Our X2 and our Y2. And then whatever that we have on the first point is going to represent our X1 and our Y1 there, okay? So therefore, we are saying that then it means that our y-axis, so y2, it represents what? It represents our y-axis there on the graph. So we can see that that's the value for y there. And it's what? It's the value of what? It is 6 there. And then from here, what is it that we have? Then we need to also identify our what? Identify our y1, and then we can see that the value there is what? Is a 2. And then we go on and we identify the value for what? We identify the value for the x-axis. Again, it's a 6. And then the value for our x1 there is a what? Is a 2. So 6 minus 2 will therefore give us 4. 6 minus 2 will therefore give us what? Give us another 4. So 4 divided by 4 will therefore give us what? 1. So what are we saying then? How do you then use this? So if they say calculate the resistance, they are basically telling you to calculate what? To calculate the gradient. So firstly, you are going to calculate the gradient. Then we are saying that because the gradient is represented by what? Change in V divided by what? Divided by change in I. Therefore, the gradient is the one that will give us what? So this is the same as us having change in V divided by change in I. And if we have calculated the gradient and we are saying that our answer for the gradient is 1, it therefore means that we have calculated the resistance. So therefore, the resistance will therefore give us what? It will therefore give us 1 ohm. So make sure that you know how to use the graph, and make sure that you know how to calculate the gradient given the gradient using 2 points. And then we are saying that from the gradient will therefore give us the what? The resistance. And then we talked about this one. It says define EMF as the potential difference across a cell when the circuit is open. So we are saying that the EMF would be the what? Would be the potential difference that you are going to measure when you have placed what? When you have placed a voltmeter across a battery, and then you are going to measure that potential difference only when the what? Only when the circuit is what? Is open there. Okay, so now we have ohmic and non-ohmic conductors. And then for an ohmic conductor, we are therefore saying that an ohmic conductor will do what? An ohmic conductor will obey Ohm's law. And with the ratio of V over I, we are saying that R remains what? R remains constant. And then with a non-ohmic conductor, we are therefore saying that a non-ohmic conductor does not obey what? It does not obey Ohm's law. And we are therefore saying that R does not remain what? R does not remain constant. But with the ohmic conductor, we are saying that it remains constant because, as you can see here, if this is a straight line and you are to calculate the gradient between any 2 points, we can see that the gradient between any 2 points there will give you the same value. But with this graph, we are therefore saying that the gradient between any 2 points will not give you what? Will not give you the same value that we have, that is in terms of what? That is in terms of R there. So again, if you are given this type of a graph, remember we said that you are going to say what? M is equals to change in Y divided by what? Divided by change in X, whereby M represents what? It represents the gradient. Okay, so if M represents the gradient, we are therefore saying that for change in Y, we have what? We have change in I divided by what? Divided by change in V. So you know that if you are then going to break it down, you are therefore going to have I2 minus I1 divided by V2 minus V1. Or else you can also have what? Or else you can also write it as Y2 minus Y1 divided by what? By X2 minus X1 there. Okay? So now if this is the case and you are then asked to calculate the what? You are then asked to calculate the resistance, what is it that you are going to do? So it therefore means that you are then going to write what? You will see that when we look at Ohm's law, we have what? We have R is equals to what? Or we have R is equals to V over I. So with the previous one, remember we had what? We had change in V divided by what? Divided by change in I. But with this one, we can see that we have the inverse now. So we have what? We have change in I over change in V. And this side we have change in V over change in I. So if this is then, if we can then divide this by 1, and we are trying to change it to that, we are therefore saying that if this is I over V, and I over V, with I over V, we are representing what? We are representing the gradient, and this is V over I. It therefore means that we can then have what? We can then have change in I divided by change in what? By change in V being what? Being 1 over R there, which is coming from what? Which is coming from this equation over here. So if you are then asked to calculate R, it therefore means that you are going to calculate your gradient. So let's say that you got maybe a 2 as your answer for the gradient. The answer would then be 2, and then you are going to divide that, you are going to equate it to what? To 1 over the R. So from there, what are you going to do to find your answer? You are going to cross multiply, whereby you can have what? 2R is equals to 1, and therefore when you divide on 2, divide by 2 on both sides, therefore your R can be what? Can be a half, which is the same as what? Which is the same as 0.5 what? 0.5 ohms. So just make sure that you know how to use all the graphs that we have there. Now we have electric power, and it says electric power is defined as the rate at which work is done, or the energy that is what? The energy that is transformed. So this is electric power, the rate. So remember, with the word rate, we are talking about change in time. The rate at which what? At which work is done, or energy is what? Or energy is transformed. So now the symbol for power is P, and then power is measured in watts or W there. Okay, so we are saying that power is measured in what? Power is measured in watts. Okay, and then we have what? We have the work done, or the energy. The work done or the energy is measured in what? In joules. And then at the bottom, we have what? We have the change in time, which is in seconds. So therefore, it means that we can then equate the two units to say 1 watt is equivalent to what? 1 watt is equivalent to joule per watt, or to 1 joule per second. And where is that coming from? This is the same as us having, it's the same as us having a joule per second. So the joule divided by the second. So therefore, when you rewrite it, it would therefore be 1 joule per second. So again, if this comes as a multiple choice questions, you would know that because we are saying that power is measured in watts, therefore we can equate this to 1 joule per watt, to 1 joule per second. So it says 1 watt of power is when 1 joule of work, so 1 joule of work is done in what? Is done in 1 second there. Then it says 1 joule of energy is transformed in what? In 1 second. So therefore, again, we are repeating what we have written there. 1 joule of energy is transferred in what? Is transferred in 1 second, according to the formula there as well. Okay, and then in terms of the formulas of power, we said that the letter P is going to represent what? The letter P is going to represent power, and this would be the work done, or the energy in joules. This would be the time in seconds. This would be the potential difference in what involves the current in ampere, the current again, the resistance, the potential difference, and the resistance there. Okay, so for the formulas, we are saying that for a constant power, so we are looking at this one, for a constant power, using what? Using different resistors, the potential difference, which is V, is inversely proportional to the what? Is inversely proportional to the current. So the potential difference V is inversely proportional to the current. Okay, so if the potential difference is inversely proportional to the current, it therefore means that as the potential difference increases, the current will do what? The current will decrease there. And then with this formula, P is equals to I squared times R, we are saying that when resistance is what? When the resistance R is what? Is constant, we are saying that the power is directly proportional to the current squared. So with this one, we can also relate power in terms of what? We can also relate power in terms of the brightness as well. Okay. So it says when when the resistance is what? So we're looking at this one. Resistance is constant. Power is directly, so the power is directly proportional to the what? Directly proportional to the current. So if the power is directly proportional to the current, it therefore means what? If we increase the current, therefore the power will also increase. If the power increases, therefore the brightness of the light bulb would therefore, the brightness of the light bulb will therefore do what? It will therefore increase there. And then it says when the resistance is what? When the resistance is constant on this one, we are therefore saying that the power is directly proportional to the what? To the potential difference what? Squared. So it therefore means that if we increase the potential difference, therefore the power will also do what? The power will also increase there. Okay. So now learners, let us look at the following questions. The first one here says 3 cells, each with an EMF of what? Each with an EMF of 2 volts. So it therefore means that we must understand what they mean when they talk about what? A cell. So it says that we have 3 cells. So this would then be representing the 3 cells. 3 cells, each, it says each has a, each with an EMF of what? Each with an EMF of 2 volts there. It says they are connected in what? In series. So the 3 cells are connected in series with an external circuit as shown in the diagram below. So it therefore means that with this one again, we then need to identify what? We need to identify where is the current flowing, okay? So we can see that because the longer side here is the positive terminal and the shorter one is the negative terminal, it therefore means that the current will be flowing where? It will be flowing in this direction. But when the current gets to this point, what is going to happen to the current? The current will be split. So if the current is split, it means that some of the current will travel to the 2 ohm resistor and some of the current will travel to the 4 ohm resistor up until where? Up until this point where it will come together. Okay, so it therefore means that by us reading and by us looking at the diagram, we can already tell which resistors are connected in what? Which resistors are connected in series and which resistors are connected in what? Are connected in parallel. Okay, so let us see now. Resistor R1 is connected in what? Is connected in series because before the current gets to it, it does not what? The current is not split, the current is not divided. It is traveling in what? Only in one path. And then let us look at R2. R2 is connected in parallel as well as what? As well as R4 as well as connected in parallel. I mean R3, but if we look at R4, we will therefore see that R4 is connected in what? Is connected in series because the current is not what? Is not split before it gets to R4. So the first one here says calculate the total resistance of what? Calculate the total resistance of the circuit. So in order for you to do this question, we are saying that you need to identify which resistors are connected in series and which resistors are connected in what? In parallel. Because remember, for resistors that are connected in what? In series, it means that you are going to use what? You are going to use this formula here. But for the resistors, depending on the number of resistors that you have there, for the resistors that are connected in what? That are connected in parallel, you are therefore going to use this formula there. Okay? So now it says here, For the total resistance, where can you start? You can start by calculating the resistance in what? In parallel. So for the resistance in parallel, we can see that we have what? We have, so it's going to be 1 over R parallel, or 1 over what? 1 over RP is equals to what? 1 over, so you can write 1 over R1 plus by 1 over R2, or you can look at what is it that you are given. So in this case, we are given what? We are given R2 and R3. So it therefore means that we can write 1 over R2 plus by what? Plus by 1 over R3. So when we do that, we are then going to have what? 1 over 2, which is substituted from the resistance in parallel, plus by what? Plus by 1 over 4. And what are we getting as our answer? We can see that we are getting the 3 over 4 there. Okay? So when you get your 3 over 4, how are you then going to solve it? So you will see that you have 1 over RP is equals to 3 over 4. So therefore, it therefore means that you need to solve it so that you can have what? So that you can have it as a decimal. But before you solve it so that you can have a decimal, then you're going to say what? 3 times RP is what? Is 3 RP, which is equals to 4. From there, what is it that you did? Divide both sides by the 3 so that you can get rid of the 3. So that at the end, you will then have what? RP is equals to what? RP is equals to 4 over 3, which is what we have there. And then if you put that in your calculator, you will see that it's giving us what? It's giving us 1,33 ohms. Okay, so now that you have calculated what? The total resistance in what? The total resistance in parallel, you will then have to calculate what? The resistance for the other what? The resistance for the other resistors that are connected in series, because the question said the total resistance of the circuit, not only the resistance of the parallel circuit. Okay, so from there, what are you going to do? You are then going to write RT is equals to R1. Which one is R1? R1 is the one that's connected in series, plus by R parallel, which is what we calculated, plus by what? Plus by R4 there. So that is what we have in terms of R4. So our R1 value is represented by 0,3. Our R parallel is 1,33. And our R4 is represented by what? Is represented by the 2 ohms there. So therefore, we are going to get a total of what? We are going to get a total of 3,63 there. So that is how you would calculate the total resistance. Just make sure that you know how to identify which one is the series part of the circuit and which one is the parallel part of the circuit there. Okay. Then next it says calculate the following, the reading on the what? The reading on the ammeter. So remember, we used R2 and R3 to calculate the total resistance in what? In parallel. After we calculated the total resistance in parallel, we did what? We added the resistance of R1 as well as the resistance of what? Of R2. With that, we then got what? With that, we then got the total resistance. So with that, we got the total resistance of what? This is the total resistance of the whole circuit. And then now the question says that we need to calculate what? We need to calculate the ammeter reading, okay? So it therefore means that we are going to use what? We are going to use Ohm's law, which is what? Which is R is equals to what? Is equals to V over I. So remember, when you write your formulas and they say that you need to calculate the what? You need to calculate the current. You are not going to start by manipulating the formula so that you make I the subject of the formula. You are going to write the formula as you find it from where? As you find it from the formula sheet. So the formula, as you find it from the formula sheet, is represented by what? By R is equals to VI. So you write exactly that. So from there, you will see that we have what? We have R. So we had calculated what? We had calculated the total resistance where by 7.1.1. So from that total resistance, it therefore means that we can then substitute the total resistance, and then it therefore means that we need what? We also need the total potential difference or the total voltage of the circuit. So now if we have the total resistance and we have the total voltage of the circuit, it therefore means that we can then calculate the what? We can then calculate the total current of the circuit. So now you will remember that we said that the EMF for each cell is what? It's 2 volts. So if we have a total of what? If we have a total of 3 cells, it therefore means that the total voltage will be represented by what? Will be represented by the 6 volts there. Okay, so this is how we are going to solve it. We said that firstly, we are going to write the formula as it is from where? From the formula sheet. Then after you write the formula as it is from the formula sheet, you can then manipulate, if you want to manipulate the formula after, or else you are going to substitute exactly what you have, and that is what without manipulating. So if you want to do a direct substitution, the potential difference will be represented by what? By a 6 there. And the resistance, as we had calculated, it was represented by what? By the 3,63 there. And it would therefore mean that from there you would have to calculate your what? You would have to calculate your current. So if we have 3,63 is equals to 6 over I divided by what? Divided by 1. What are you going to do? You are then going to cross multiply. 1 times 6 is what? Is 6, which is equals to 3,63, which is equals to 3,63 multiplied by I. So you would have that, and therefore it would mean that you would have to divide both sides by I. So when you divide both sides by I, you will see that you are getting what? You will get an answer of 1,6 watt, of 1,6 ampere there. Okay. Then it says, what will be the effect on the ammeter reading if the total resistance of the circuit increases? Now we said, what is the relationship between the resistance and the what? Between the resistance and the current. Okay. So the question says, what will be the effect on the ammeter reading? So the effect on the ammeter reading if the total resistance, if we increase the resistance. So increasing the resistance means that we are increasing what? We are increasing a blockage in the circuit. So if we increase the blockage in the circuit, what will therefore happen to the current? So we are saying that the current will therefore do what? The current will therefore decrease. Why? Because the relationship between the resistance and the current is that they are inversely proportional. So it therefore means that as the resistance increases, so it therefore means that as the resistance increases, the current will do what? The current will decrease. So it's an inverse relationship. So we are saying that if the total resistance increases, so this is what represents the resistance. If the total resistance increases, therefore the current, the total current as well, is going to decrease because the two are inversely proportional. Okay. Then it says, so now the next one says we need to state what? We need to state Ohm's law in words. So remember with definitions, we said that we are going to define according to the examination guideline. So it says that the potential difference across a conductor is what? Is directly proportional to the current. So the potential difference across a conductor is directly proportional to the current. Remember we said we're not going to stop here in the conductor at a what? At a constant temperature. So we must just remember to mention that it is going to be what? At a constant temperature. So now that would now be a full definition for what? For 2 marks there. 9.2 says 3 identical bulbs A, B, and C are connected in an electric circuit as shown in the diagram below. Okay, so we can see that what is happening. We have the positive terminal, we also have the negative terminal, and then it therefore means that the current is going to flow from where? From the positive terminal all the way to the negative terminal. But when the current gets here, we can see that the current is what? The current is divided up until it gets to this point where it will come together, and then again we will have this part here would therefore be a connection in what? In series. So light bulb A is connected in what? In series. Light bulb B is connected in what? In parallel. And then light bulb C is connected in what? In parallel as well. So the question says, how would the brightness of bulb A compare to that of bulb B and C? So how would this one, bulb A, compare to the brightness of bulb what? Of bulb B and what? B and C. So now we would now see that because bulb A is connected in what? Connected in series, it therefore means that the total current by a light bulb A would be bigger than the what? Than the current that we have between light bulb B and light bulb C. In other words, we are saying that because light bulb B and light bulb C are connected in parallel, we know that with a parallel connection, the current is what? The current is divided. So it therefore means that if the total current, for example, for this light bulb is what? Is 3 ampere. It therefore means that some of the current will then travel to light bulb B. So let's say, for example, maybe the light bulb B gets a current of 1.5 ampere, and light bulb A gets a current of what? Of 1.5 ampere as well. We are therefore saying that if we are going to compare then the power and the what? The power and the current, we are saying that power is directly proportional to the what? Is directly proportional to the current. So it therefore means that whichever light bulb there that will have what? That will have a greater current, it therefore means that in terms of the brightness, that light bulb will be brighter. So if we now go back to the diagram, we will see that the light bulb A is connected in series. So therefore light bulb A has a greater current. So because light bulb A has a greater current, it therefore means that it will have what? It will have a greater power. And because it has a greater power, it therefore means that light bulb A would therefore be what? Would therefore be brighter compared to the others. Why? Because we are saying that light bulb B and C, they are connected in what? They are connected in parallel. So because they are connected in parallel, it therefore means that the current between the two is divided. So because, for example, they will each have, as an example, they will each have a current of 1.5 ampere, which is smaller than the current of A, which has a current of what? 3 ampere. We are therefore saying that if now we are saying that the current is directly proportional to the power, therefore, because this one, the B and C, has a smaller current, it therefore means that in terms of power, there will be less power, and because there will be less power, it therefore means that B and C, they will be dimmer compared to what? Compared to letter A. So our answer then would then therefore mean that letter A would be what? It would be brighter because of its current then. Then the next one says, an electric ion has a power rating of what? Has a power rating of 1,500 watts, okay? So we are given the power, okay? So it says has a power rating of 1,500 watts. Then it says if the potential difference across the ion is what? So if the potential difference is what? Is 230 volts, then it says that we need to calculate the what? We need to calculate the resistance. So it therefore means that for this one, we are then going to look at your what? You are then going to look at your formula sheet to say which formula has power and which formula has what? Which formula has potential difference, and as well as what? As well as the resistance, okay? So we are therefore going to use this one. It has power, it has the potential difference, as well as the what? As well as the resistance. So again, we are going to write the formula as it is on the formula sheet, and then you can manipulate after you have written the answer. So our power is what? Is 1,500 watts, and then the potential difference is represented by what? It's 230, and we are therefore calculating the resistance. So how would you then get your answer there? It means that you are going to cross multiply. When you cross multiply, it would be 1 multiplied by 230 squared is equals to what? 1,500 multiplied by what? Multiplied by R. So from there, what is it that you are going to do? We are going to divide by 1,500 on both sides. So therefore, you would then calculate your R, and your R would therefore give you 35, what? 35,27 there. Okay, now the next one says how much current flows through the what? Flows through the ion. So for this one again, it would therefore mean that you would then again look at your formula sheet and look at a formula that will then give you what? That will then have your current there. So it means that we are now going to have power is equals to what? Power is equals to VI there. And already we had what? Already we had the power, which is in watts, and already we had the voltage. So it therefore means that we are able to calculate the what? We are able to calculate the current there. So again, with all the formulas, you need to make sure that you write the formula as they are, and then you then substitute, and then from there you need to make sure that you write your what? You write your answer, and that you also give what? You also give your unit. For 9.3.2, it was saying how much current. So hence that's why we are going to write what? Hence that's why we are going to write ampere there. And for this one, for 9.3.1, it said what? It said calculate the what? Calculate the resistance. So hence that's why we are going to write what? The symbol for resistance, which is what? Which is represented by ohms. Next one says define power in an electric circuit. Okay, so it says here it is the rate at which electrical energy is converted in what? In an electric circuit. So again, we are saying that for these ones, we just need to make sure that we use what? We use the examination guidelines. Okay. Then with the next one, it says a heater with a single element is marked the following. So this heater is then marked what? Is then marked 60 watts. So it means that you then need to identify that, okay, if you have the word W, what is the word W? Or the word W, it represents what? In this case, it's representing the power. And then 220 V, what does it represent? It represents the potential difference. Now it says calculate the resistance of the what? Of the heater element. But can you see that with these questions, if you are not able to identify the units, it therefore means that you will also not be able to identify what? You will also not be able to identify the correct formula. So you need to make sure that you know the units that we are using so that you are able to identify the correct formula. So with this, then it means that you are then going to use your formula sheet, and then you are going to look for what? Where you have what? Power, where you have the potential difference, as well as where you have the resistance there. Okay. So we have what? We have P is equals to what? P is equals to V squared divided by what? V squared divided by R. So this one, it would be a straightforward one, whereby you are going to replace what? To substitute the power, we are going to substitute the voltage, as well as substituting the what? As well as writing the what? Writing the resistance. So from there, it would therefore mean that you are going to divide by what? Divide by 1 then. So then how are you going to find R? It means that you are going to cross multiply. So that you have what? 220 squared multiplied by 1 and 60 multiplied by R. Then what are you going to do? Divide both sides by R, and then you will see that for your R, you are going to have 220 squared divided by 60, and that will therefore give you an answer of what? 806,67 ohms. For option number 2, then you can then use what? P is equals to VI, whereby you are going to substitute your power, you are going to substitute your potential difference, and then you can calculate the current there. Okay, so and then you can calculate the current there. Okay, and now for from here, it therefore means that you are then going to calculate what? You are then going to use Ohm's law again. And then with Ohm's law, you can substitute what? You can substitute your current, you can substitute the potential difference, and then you can have your what? You can have the answer there for resistance in what? In ohms. With option number 3, we are saying that you are going to have the power there, you substitute it, and then you are going to have what? The voltage, which is 220, the current, again you are calculating the current. After you have now calculated the current, what are you going to do? You are going to use this formula, which is what? P is equals to I squared multiplied by R, and then you have what? Power. So you substitute the power, which is 60 watts there, the current, which you calculated here, and then you are again going to calculate the resistance. So you will see that with all of the answers, we are not really getting the same what? We are not really getting the same decimals there. So, but as long as you have used the correct what? You have used the correct formulas, then we should be okay there. So, okay, learners, I'm just going to ask that we just take a 1 minute break, learners. A 1 minute break. Okay, so welcome back, learners. And we have now ran out of time. So what we are going to do is that we are then going to give you homework. So you can then complete the following. So we had 9.3. Then we had the following, which is again from the previous question papers. So that was going to be your 6.2. Then again, the question continues. So again, you can then complete this as your homework then. Then it's 6.2.4. Okay, so thank you very much, learners. And I'm going to leave you with the words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." So thank you very much, learners, and I'll see you next time. Goodbye for now.